Hello everyone, this is Dr. Sulaiman Khan and you are watching my YouTube channel, The Beauty of Mathematics. In today's lecture, I would like to discuss about the orthogonality of the Legendre polynomials. The Legendre polynomials satisfy a relation of the type integral from -1 to 1, polynomial of order n, polynomial of order n, m, dx equal to 0, where m and n are not equal to each other. So this kind of relation is called the orthogonality property. To prove this relation, as we know that the Legendre polynomial Pn satisfied the Legendre differential equation of this form 1 minus x square Legendre polynomial derivative double derivative minus 2x first time derivative plus n into n plus 1 Pn equal to 0. So the equation 2 can also be written as in simple this form, differential of 1 minus x square Pn dash, because this is the product rule. When we multiply apply the product rule, this is the first term into derivative of the second, which is Pn double dash plus second term Pn dash derivative of the first, which is minus 2x. So this in short can be written as in this form of differential, and the last term is in its own position, this one. So to prove one, we must note that the fact that both Pn and Pm satisfy the Legendre differential equation 3, and we can express these Pn and Pm while satisfying this equation 3 in this form. When Pn is satisfying this equation, so that is the same as equation 3. When Pm satisfied this equation, so we will replace Pn by Pm over here, so we can get this equation 4 and 5. Now we will multiply equation 4 by Pm and equation 5 by Pn. So when we have to multiply equation 4 by Pm, we can get this differential equation, and when we multiply equation 5 by Pn, so we can get this equation. Now we have to subtract the equation 7 from 6 and integrating from -1 to 1, so we can get this result. Integrating from -1 to 1, this term minus this term, and integrating this as well as this, but we have to subtract this from equation 6, so we can get n into n plus 1 minus m into m plus 1 time this integral of the two term we have taken common over here, integral -1 to 1 Pm x Pnx, so we have taken this common, and now we will simplify this equation 8 integrating by parts. We will evaluate this first integral in the equation 8. So we have taken this one here, this is the first integral and this is the second. So while using the integration by parts, this is the first term and integral of the second, like this one, minus double integral of this term, the second one, and derivative of the first, which is Pm dash, this one. So to find the integration of this term over here is this one. So as here the derivative and the integral will cancel each other, and we will get 1 minus x square Pn dash, the limits are from -1 to 1. Similarly, this integral and this derivative will cancel each other, we will get the integral from -1 to 1 minus x square pn dash pm dash x. So now we have to simplify this term. So as we consider 1 minus x square, and the limits are from 1 to -1. So since 1 minus x square vanish at x is equal to 1 minus 1, means when x is equal to -1, the value of 1 minus x square is 0, and when x is equal to 1, also the value of 1 minus x square is 0. So we can get 0 from this expression, and just we can conclude that this integral is equal to this term, the integral of minus time the integral of this term. So in equation 8, as we have considered this term, so its integral is equal to minus time no, the integral from -1 to 1 minus x square pm dash dx. Similarly, we can also take this integral, the second one in the equation 8, and we can get the same result like this one in the next page, as we see. Similarly, the second integral in equation 8 can also becomes by the same procedure. While using integration by parts, we can get this value. Now we will substitute the value of equation 9 and 10 in equation 8, and clearly the difference of these two integral is 0, because this one is negative time this integral, and this one is also negative time this integral. Both the integrals are the same, so when we get minus time this integral value, minus time, one minus is here and another minus is also here in the equation 10, so this will become plus, and this integral as well as this one will become same. So this will be minus and this will be plus, so both can become 0, and finally we can get just this result in the equation 8, which is given over here, this one. So now we will simplify this expression, this one, and we can get n into n square plus n minus m square minus m. So now we have to simplify this one, little algebraic simplification. For example, we will use n square minus m square formula, so we can get n minus m time n plus m, this is plus n, this is minus n, so we can write it to our n minus m. So this one and this one, these two are the same, so we can take this common. It will be left here n plus this will be n plus m, and here it will be plus 1, so we can get this factorization. So now this is the limits from -1 to 1. So now either the multiplication of this one term, second term, and this third term is 0. So it means that either this first, second, or this third is equal to 0. So we will discuss all these three cases one by one. Now as m and n are some non-negative integers, so when n and m are non-negative, so when we add 1 with them, so it is sure that it will be not equal to 0, because n and m are also non-negative integer. So either the value of nm is 0 or greater than 0, 0, 1, 2, 3, and so on. So if both of them are 0, so 1 is not equal to 0, so this case is obvious. And for all other positive integer, it is also true. So the second case, if we consider this one is okay, this is not equal to 0. So if we consider this one n minus m, if also as we have discussed in start that n is not equal to m, so when n is not equal to m, so their difference is also not equal to 0, because both are not equal, so their difference is also not equal to 0. So it means that this term is also not equal to 0. So surely there is only one chance that the value of this integral is 0. So we have concluded that integral from -1 to 1 pmx pnx dx equal to 0, where when m and n are not equal to each other. So it means that the Legendre polynomials are orthogonal, or this is the orthogonality condition for the Legendre polynomials. So it is all about the orthogonality of the Legendre polynomials. So thank you so much. See you next time.